Hello and welcome to another Viri feature short demonstration. In a previous video, Volumetrics Part 1, we talked about the Viri environment fog and Viri area perspective effects. In this second part, we'll examine the Viri volume grid, which allows for loading and rendering volumetric cache files such as OpenVDB, View3D and PhoenixFD Aura files. As its name suggests, the Viri volume grid is a three-dimensional grid which contains volumetric data. This data is typically generated by fluid simulation software and stored as cache files. The most common formats include OpenVDB generated in Houdini, View3D generated in FumeFX, and Aura generated in PhoenixFD. The data consists of many equally sized cubes called voxels. Each voxel holds a value that can have different meanings, such as density, temperature, velocity, and many others. Those are called channels. A cache file can contain a great number of voxels, and for each of them, there could be multiple channels. The Viri volume grid reads all this data and uses it to apply different shading to the voxels at render time. For example, the density channel can drive the opacity, and the temperature channel the self-illumination. In addition, there are possibilities for remapping the cache data for greater artistic freedom. Let's take a closer look at the Viri volume grid. It's a container that provides the interface for loading and shading volume data. When a volume cache is loaded, Viri volume grid suggests loading a preset for the most common formats. This adjusts the grid settings so that the volume data renders correctly. Those presets provide a great starting point for shading. Since the cache file has information for the fluid data only and no shading information, manual adjustments may be required if closely matching look is desired. In this particular example, an OpenVDB file is loaded so the Houdini Fire Smoke preset is chosen. On a successful load, the grid is resized to the cache's dimensions. If you would like to apply a preset after the cache has been loaded, you can do so by using the Render Preset button. The frame info rollout contains general information, dimensions measured in voxels, and available channels. By default, non-empty voxels are displayed as color-coded triangles. If the viewport performance degrades, the detail reduction setting can be increased. That preview downsizing can be done by Phoenix automatically. A great way to analyze the value range is adjusting the preview limits and their colors, enabling the auto range checkbox, or previewing only a slice of the grid. Alternatively, a GPU preview can be enabled for better viewport visualization. Let's have a look at the render. The rendering process could be accelerated by a couple of optimizations. Let's increase the rendering steps to the point just below artifacts appear. The step size is measured in percentage of the size of a single voxel. In this case, a value of 2000% would suffice, and since there is some detail in the shadows, a value of 2000% would be used as well. In addition, as a Viri 3.3, probabilistic shading can be utilized for faster volumetric rendering. As mentioned earlier, different shading aspects for each voxel can be controlled. This can be done through the volumetric options dialog. The fire rollout controls the self-illumination of the voxels. The smoke color controls their color when illuminated by light, and smoke opacity sets the visibility of each voxel. These can be set using a single value for every voxel. Let's change the smoke color. In addition, a channel from the cache can be used to give each voxel a different value. Let's set the color to be driven by the temperature channel. In this case, a remapping ramp can be used to fine-tune or greatly alter the appearance of the fluid. In the ramp, the existing volume data is represented with a cyan band. Currently, it's in the 0 to 46 range. That's why the ramp needs to be readjusted. The color flags have a number below them which corresponds to values from the volume data. Voxels containing that value in the temperature channel would be filled with the corresponding color. Using the same approach, we can adjust the emissive part of the shader, the fire. Depending on your setup, the emission strength may have to be increased by this multiplier. A similar approach can be used for remapping the opacity. However, a curve is used instead of a ramp. Let's base it on the smoke data channel and make it more transparent. Now let's increase the opacity for the lower values only. This way a fine smoke look such as cigarette smoke can be achieved. Lastly, all the emission, color and opacity can be modulated by a 3D texture. There are several parameters controlling how light is scattered inside the grid. By adjusting the multipliers, different effects can be achieved. Since emission relies on GI to illuminate other objects, it is often a computationally expensive effect. That is why the V-Ray volume grid automatically generates lights with the appropriate color and intensity that match the emissive part. This speeds up the rendering and improves the quality. Another functionality of the V-Ray volume grid is its multiple rendering modes. They interpret the volume data differently. For example, the mesh and implicit surface generate hard surface based on a level threshold. And the ocean mode generates infinite flat surface meant to complement a water surface simulation. However, this is not the case in this particular example and artifacts appear. So let's switch back to mesh mode. For preview purposes, show mesh can be enabled. This way, if deforming modifiers are applied, their effect can be seen in both the viewport and the render. Let's apply a relax and twist modifiers. A refractive material can be applied so that the grid renders as a transparent liquid. Let's change the coloration of the liquid as well. Additionally, a displacement effect can be enabled, which will provide even finer control over the surface. Note that the displacement works only for volumetric modes. There are some more advanced modes such as the volumetric heat and volumetric geometry that are used in specific situations. Let's load up a more complex scene so we can see the V-Ray volume grid in context. In this short video tutorial, we have covered how the V-Ray volume grid objects in V-Ray can be used to load volumetric data and render it as fire, smoke, surface and infinite ocean. I hope you have found this video useful and helpful. Make sure you check out more V-Ray featured videos. Thank you for watching.